Hey, mathematicians, here we are with section 9.2. We're talking about translations. Again, continuing on that whole idea of transformations and getting into synergy or getting into symmetry. All right, so what is a translation? It's where a slide, it's a glide. Those are all the different names that you've used with it. But we're going to use vectors to help us when we're doing our translations. And we talked about vectors in the last chapter, so we're going to be building on that as well. Okay, so a translation vector is a function that maps each point on its image along a vector. Okay, that vector is called a translation vector. Each segment joining a point and its image has the same length as the vector, and this segment is also parallel to the vector. All right, so let's take a look at what an example of this is. Okay, so if I have this figure, okay, so this kind of shows me I've got x, y, z, and this is my vector. It means that each point, each vertice is going to go along that same vector. And you can see that drawn right here. All those vectors are parallel, and it just shows that they're all moving, right? They're all sliding over. So what is a translation in a coordinate plane? Symbolically, we see it written this way, right? So to translate a point along a vector, and notice how we bring back component form here, A, B in component form, you add the A to the X coordinate and the B to the Y coordinate. So when you look at it, if the image is -2, 3, the vector is 7, 4, then you take -2 plus 7 to get 5, 3 plus 4 gets you 7, and that's how you find your new point. So we're going to practice that. So we're using vectors to help dictate our translations. So we're going to graph TUV using the vertices it gives. So -1, -4, that's T. 6, 2, that's U. And then 5, -5, and that's V. And then we do this. There we go. All right. Now we're going to move it along the vector -3, 2. So I'm just going to write over here TUV, T prime, UV, U prime, and V prime. And I'm moving it along the vector -3, 2. So that means I'm going to add -3 to the X value. That gives me -4. I'm going to add 2 to the Y value. That's -2. So T prime is going to be -4, -2. T prime. U is going to be 6 minus 3 is 3, and 2 plus 2 is 4. So I'm going to go for U, I'm going to go over 3 up 4. That's going to be U prime. And then V, 5 minus 3 is 2. -5 plus 2 is -3. So I go to 2, -3, and that's going to be my V prime. And so when I look at this new figure, all of those pieces, if you follow the vectors, are going to be parallel. Here's a vector, here's a vector, and there's the vector. So you can see that they all move along parallel. And so these are all my new images. All right, so let's graph penta with the vertices 1, 0, 2, 2, 4, 1, and move it along vector -5, -1. So I'm going to start by putting my points. 1, 0, 2, 2, 4, 1, 4, -1, and another 2, 2. Whoops, 2, -2. That's where I missed it. There we go. So here's my figure. All right, my pentagon, and it's going to be moved along the vector -5, -1. So I'm going to do P prime is going to be -4, -1. So I go -4. Let me switch colors too. I think sometimes it's easier to see that. So -4, 1, 2, 3, 4, -1. That's going to be P prime. And then E prime is going to be 2 minus 5 is negative 3. 2 minus 1 is 1. So I'm going to go back 3, 1, 2, 3, and go up 1. That's going to be E prime. And then N prime is going to be 4 minus 5 is negative 1. Negative 1 plus 1 is 0. So negative 1, 0. That's N prime. You see kind of how we're doing this? We're taking that vector and we're adding it to the coordinates. So 4 plus negative 5 is negative 1. And negative 1 plus negative 1 is negative 2. That's going to be my T prime. And then A prime is going to be negative 3, negative 3. Right here. And there it moved the vector. Okay. All right, so this graph shows repeated translation that results in the animation of a raindrop. Okay, so those of you who want to be animators, we've got some pretty talented artists in this group. There might be your calling, and this is where you use geometry. Describe the translation of the raindrop from position 2 to position 3 in function notation and in words. So function notation is going to be x, y. That's how it starts. And then it moves to x plus something, y plus something. So let's take a look. From 2 to 3, the x goes back 2. So it's going to actually be x minus 2 because my x is going back 2. And my y is going down 3. So it's going to be actually x minus 3. So that is your function notation. And then from here in words, kind of what I said, your x goes back 2, your y goes down 3. Now the graph also shows or describe the translation of the raindrop from position 3 to position 4 using a translation vector. So using a translation vector. So here we go. We're going to put it in component form. All right. So from 3 to 4, it stays the same, and the y goes down 3. So that's how much it's going to move. All right. Have a great day. I know I went through this kind of fast, but you've got it. Check me out in class. See you later. Bye.